If we're now not encoding categorical data, but instead we make observations over time, let's have a look how we can visualize those kind of data. First of all, we're already familiar with the area chart, so let's have a look at that. So here we have 4 pie charts for time point 1, time point 2, time point 3, and time point 4. And I'm going to ask you now to make a quick observation of whether in any of these categories, category A, B, C, or D, is actually changing at all over my 4 time points or not. So what you probably will do now, either with a ruler or by eye, to draw kind of comparable lines across the 4 data points. So if you start here with D, for example, you can see the beginning and the end is on a horizontal line. If you make a horizontal line from the other edge of the slice D, you will notice that it doesn't reach the same point, so it looks like D is slightly increasing. If we know one slice is increasing in a pie chart, some other slice actually will have to be decreased. So you can go on and do this for all of the slices, and you will be able to figure out what exactly the changes are. This is very time consuming, and beforehand I had advertised that encoding quantities with bars is a better idea than with area because it allows us to make more precise comparisons. So let's try that. Now we have the same data encoded with bar charts. So here's our first time point, our second time point, our third time point, and our fourth time point. And again, we make observations for category A, B, C, and D. So in this case, again, what you will probably do by eye is to make horizontal lines across the time points in order to see what changes and what doesn't. Very quickly, it's apparent that the bars representing category A sort of remain the same, pretty much identically remain the same. However, if we draw the horizontal line for the category C, we can see that somehow it drops below the red arrow. And if we do the same for D, we can see that the bar grows, becomes bigger than the horizontal arrow. So we can actually figure out what change is happening by making these sort of helpful horizontal lines. So since in both cases we were able to figure out what change is happening by using horizontal lines, this really is bringing home the fact that the best way to visualize time course data and any change is by simply plotting only the lines. So if we plot for the category A, the 4 time points, we see there's 0 slope increase or decrease. The line is absolutely flat. The same is for B. However, we very quickly see that the line for C has a slight decrease, while the line for D has a slight increase. So if you compare all the 3 ways, I think it's very, very obvious that the line is really the best way to encode time course data, because our eyes are really, really good in perceiving even a 1% slope change. So keep that in mind, and for any kind of time you want to show temporal changes, immediately go to line charts. So the most easy one of those is obviously to simply plot for one or as many categories as you want the different time points across the different amounts over the different time points. As I said before, our eyes are very quick in figuring out that a slope increase means an increase in the data, and a slope decrease means a decrease in data. All you need to do for that is to make sure the 0 is at the bottom and the y quantities actually increase along the axis. So the problem comes when you only have 1 or 2 time points. For 1 time point, I said before, if you have only 1 data point, try not to use a visualization in the first place. However, if you have 2 time points, the line plot quickly looks quite lonely and sad, unless you try using the slope graph. So that's kind of a new invention in the DataViz field. Hasn't been used very much, which is why I bring it to your attention. So the slope chart basically, or slope graph basically visualizes only 2 dots and makes a connecting line between these 2 time points, for example 2000 and 2016. What it's really great for is that you have actually a lot of space for direct data labels on both ends. So you can add a lot of precision and without losing a lot of space. And what is absolutely critical is to never switch these around. So you always end up having trouble if you use bar charts for time course data, because basically what you then end up doing is to fit data into artificial bins or categories. So 2014 becomes a single point, 2015 becomes a single point, and 2016 becomes a single point, while what we actually usually want to communicate with time course data is the change and the rate of change over time, which is much more visible if you have a line. What is extremely and really even more trouble is to have connecting lines for categories, so to misuse a line chart for categorical data. So imagine categories A, B, and C are people of a certain age group, people younger than 10, older than 10, and older than 20 or something. There's nothing that actually connects these people. There are different bins for data. But by forcing them to be connected with a line, we end up confusing the perception of our audience very much. In the exercises, there is an example that you will be able to have a look at where this is the case. So for a few data points and a few categories, line charts work really well. What do we do if we have a lot of time course data and many lines? So this quickly looks very messy, but there are ways of what you can do. So here we see an example from Neri Kim, and it's numerous lines. I cannot even count how many lines are visible here. So each line is a single observation from an embryo post-fertilization. So something is happening in this specimen. So what works really well here is that the group decided to make very thin, almost transparent lines. And while we cannot see individual data points at all, what we are able to perceive is a general trend in the data. So if you have a lot of lines and you just want to get across of what overall is happening, then you can use such an approach. An alternative approach is shown here is shown here in a diagram from Edward Tufte. You can also visually tear the lines apart. So here, each observation actually gets a single line. And what is really nice is that our eyes don't care how large lines are. We can still see changes and events happening across the line, even if the line itself becomes very tiny. So visually taking the different lines apart is one possibility. And then on the right-hand side, we can see here called a Sankey diagram, where we also track from 1999 to 2009 or so over many years, all the papers that were published in different subjects of biology. And what you can see here is that a lot of lines actually work quite well. So I want you to take home from this unit that relationship diagrams, line charts, and bar charts or area charts actually go a really long way. All the audiences that we are communicating to are familiar with this kind of charts since primary school. Every one of us knows an underground chart from a city. Every one of us knows pie charts since primary school, etc. So you cannot go wrong with these kind of charts. And the message that we want to communicate is usually most clear if we stick to simple chart types.